Hello everyone. I welcome you all back to the last part of the first chapter of number system in CRT syllabus. Today we are dealing with the last part 1.6 that consists of laws of exponents for real numbers, and this is going to be the end of the chapter, and the length of this session going to be pretty small compared to the others. Why? Because we have left concepts remained to deal with. Today, moving forward to the concepts, we have to study with the exponents of the real numbers. We are dealing with the real numbers. We know what is real number is, and directly we are dealing with the exponents of the real numbers. We have several laws here. I have 4 laws here and several concepts to deal. Now going to the nomenclature, here the A, what you see, whichever A you see here corresponds to the base. A is nothing but a base, and B, whichever you see here, that is also a base. A is equal to base and base is equal to B, that is nothing but B is also equal to base. In the sense both A and B are base. And what you see here, M, N, M plus n, or wherever you see what is M and N, they are exponents. They are not in the base region. They are in the form of powers to the base, and they are known as exponents. That is nothing but M is also exponent and N is also a exponent. Now we are going to deal with the first law. If you see, look at the first law states that if you are multiplying same number, A is also a same number, this A is also a same number. Suppose here there is a 7 and here also there should be a 7 for this law, and if you have 7 power something, let us say M, and it is multiplied with another 7 with power n, then the answer is going to be 7, that is A, to the power of sum of the exponents. Let me show you the, see, let us think A is 7, or else you think any number. Let us take 5, and we have different exponents here. 5 power 2 multiplied by 5. This symbol is for multiplication. We cannot write into. I am writing this dot for multiplying. 5 power 2 into 5 power 3. Let us take, and this is going to be, see, what you should notice here is the 5 and the 5, they are both are the same number. If you take here 6 and if you write here 7 and they are different number, then you cannot apply this law. This law of exponent is not applicable for such. There should be same number on both sides, and if they have different exponents, then you are supposed to add those exponents and keeping the base same. 2 plus 3 is 5. This is equal to this one. And with the same thing here, if we have A power m, some number power m, and whole power n, then this is going to be multiplication of this inner exponent is multiplied to outer exponent, that is multiplication of this exponents. This is in the sense 5, let us take 25 power 2. You know 5 into 5 is 25. We can write this as 5 square. 5 into 5 is 25. 5 square whole power square. See, I wrote 25 as 5 square. 5 square is equal to 25. And this 2 is given here also. 2 is, I wrote this 2 as same as it is, but I changed this 25 to 5 square. Now the answer is going to be 5 power 2 into 2. How much? 4. This is what this law says. You are supposed to multiply the outer and inner exponents. This is second law. This is first law. This is second law. Now coming back to third law, it states if you have a like numbers, this number should be the same. If you have a like numbers in the numerator and denominator, if numerator number is raised to an exponent m and denominator number is raised to an exponent n, then if m is greater than n, then you can write that as a or a number base to the power of m minus n, to the exponent of m minus n. Applying this, 7 to the power of 3, 7 to the power of 1. This is going to be equal to 7 to the power of 3 minus 1, which is 7 square. See, this is the thing in our third law, exponential law. Here what it states, what you should notice here is the number both in the numerator and denominator should be same, like they should not be a unlike terms, unlike numbers. You should notice that they both are like terms. And coming to the fourth law, this is not a like terms. See, here we are dealing with like terms. This is a single number, single term. Here we are multiplying two numbers raised to a same exponent. Here the numbers are like, here the exponents are like, but the numbers are unlike. Unlike in the sense different, like in the sense same. Here the numbers are unlike and exponents are like. So we can write this as we multiply numbers and we raise both of them to a single exponent. Showing this, 5 power 2 multiplied by 6 power 2. Exponents are same, 6 power 2. Exponents are same, but the numbers base are different, 5 into 6. You can multiply this as 5 into 6 into 2 into 2 should not be written as 4, you should write it as 2. The exponents remains same. Please make sure that here both AA should be same, here AA should be same. Here when the bases are different, you are not supposed to add the exponents. You should write the exponent as A itself. Without knowing, you will write the exponent as 2 into 2 going to be 4. No, that is your major mistake in this particular exercise. You should avoid that. Now we completed the first basics of 4 laws. Coming to the some important results. These are not a laws but results. What is some number raised to the power of 0? Here the exponent m is 0. What is the answer of that number? Take any number. Let us take 2020, the year which we are. Let us take 2020. That is a number raised to the power of 0. What is the answer? The answer is going to be 1. You cannot write 2020 power 0 is 2020. If 2020 power 0 is replaced by 2020 power 1, then you can write the answer as 2020, that is 2020. If the power is raised to 0, then the answer should be 1. Take any number. You can take here 3000, 3, 4, any number, the answer is going to be 1 if and only if the exponent is going to be 0. That's our first result. You should remember all those things. Please make a note of this in your notes or wherever you are writing or wherever you are following the respective chapters. In the second case, this case is something like this one. If there is no number in a numerator and the number is 1, and in the denominator the number is raised to the exponent of n, then this is going to be this a comes to numerator with the changing the sign of the exponent, that is negative of a raised to the power of negative of n. That's this result. This is something, if this is going to be 1, then this formula results in this form. You get it, I hope. If a power m is 1 here. Suppose m is 0, then a power 0 goes to 1, and this is the interpretation of this law. This gives to a power minus n. Simple. Then here a power m square root of, this is not a square root, root of n. See, if here n is 2, then we will say this as square root, and if this n is not mentioned, then you are supposed to tell that as a nth root. Nth root of a power m. What's the answer? See, now I am going to tell you something. What is square root of 5? This is nothing but, the square root is nothing but, if the square root is in the sense the value of n here is 2, sorry, the value of n here is 2. Square root in the sense, this is nothing but 5 to the power of half. 5 to the power of half. If there is cube root of some number 10, then this is nothing but 10 power of 1 by 3. What I am doing here, that is nothing but whichever is the root we are taking here should be raised as a reciprocal. We cannot write this 3 in a numerator, that is raised as a reciprocal to this same number. That is in the form of a power, this is in the form of a root. I hope you got that. Here this is something like, if you take out this is a power m whole power 1 by n. This is taken as this. A power is, m is a number, let us take a power m is a number, and nth root given, and I am dividing 1 by n, whole thing divided by 1 by n. Now here if we consider this law, a power m, sorry, this law, a power m into n going to be a power mn. Here also same thing, a power m into 1 by n, that's going to be a power m by n. Why? We are multiplying numerator with numerator, m into 1, m, and here denominator is nothing in the sense 1 into n, n. We are getting this as this. You should remember this conversion, important. If you didn't get this, please rewind the video and make sure you get this point. Now we are done with this concept. Now here there is another result interpretation. Here it is nothing but same thing. If any number is given as root a, nth root a is equal to b, then we can write this as in this form. What? That's the root, whatever is present here, if we take this root to this side, that's going to be in the exponent, that's going to be in the exponent form, but not as a reciprocal form like this 1 by n. If we are writing a, nth root of a as a exponential form, then we would write like this. Nth root of a can be written as a power 1 by n. That's what I told here. But here if we take this n to the opposite side, n to the opposite side of a equal sign, if you take that to the opposite side, then it's going to be b power n is equal to a, and that b should be greater than 0. Here also a should be greater than 0. Why? Because that is within the square root and we are dealing with the real numbers. This is complete. This completes your 1.6 concepts. Please remember this for your reference. Now as usual we will look into problems. Now in this session I am not going to solve all the problems. Here what we need to do is the one which is given to you as a simplify, please do that on yourself. Why? Because the answer is given in the textbook itself. If you concentrate on what which I am doing, then you are capable of doing all those simplify problems, and the answer itself is given in your textbook. Now let us directly go into the exercise problems, taking the first exercise of the 1.6 exercise problems. First question is 64 to the power of half. This question is nothing but 64 square root of 64. You know this question is nothing but square root of 64. If you know what is square root of 64, you can directly write it as 8. Why? Because square root of 64 is 8. 8 into 8 is 64. If we go through the law of exponents, then we are going to do in this way. We know 8 into 8 is 64. So write 8 square is 64. 64 is written as 8 square, and half is retained. Now what? This is of the form a power m into n. This form a power m into n. What is going to be a power mn? A power mn in the sense 8 power 2 into 1 by 2. 2 cancel, 8 power 1. This is going to be 8. Simple one. Now going to the second problem of same main. In the second problem we are dealing with let us take a question. Question is something like 32 to the power of 1 by 5. 1 by 5. See, 2 power 0, 1. 2 power 1, 2. 2 power 2, 4. 2 power 3, 8. 2 power 4, 16. 2 power 5, 32. I hope you know this. 2 power 1 in the sense 2 into 1, that is 2. 2 power 2 in the sense 2 into 2, that is 4. 2 power 3, 2 into 2 into 2. 2 into 2, 4. 4 into 2, 8. 2 power 4, 2 into 2 into 2 into 2. 2 into 2 multiplied by 4 times. 4 times, that's giving to 16. 2 power 5 in the sense multiplying 2 for 5 times. Now we know 2 power 5 is 32. We can write this 2 power 5 whole power 5, and a power m into a power n, that's going to be 2 power 5 into 1 by 5. That's going to be 2. This is your second question. See, if you learn these concepts, if you are correct, perfect, thorough with these concepts, this is nothing for you guys. You know, if you learn basics maths and if you are strong with basic maths, then your higher studies will be going to be as smooth as possible. That's going to be smooth but not easy. Remember, 125 to the power of 1 by 3 is your next question. That's going to be, if you know 25 into 1, sorry 5 into 1, 5. 5 into 5, 25. 5 into 5 into 5, 125. This is nothing but 5 power 1. This is 5 power 2. Why? Because 5 is multiplied twice. 5 power 3. Why? Because my 5 is multiplied thrice. Now this is 5 power 3. 5 power 3 multiplied by 1 by 3. This is going to be 5 power 3 by 3. Same thing. All are same case. A power m into whole power n. A power mn. This is going to be 5. Taking, sorry, there is no fourth question. Let us go to second main first question. Taking second main first question itself 9 power 3 by t. and power 3 by 2. We know 3 square is 9. 3 square is 9 whole power 3 by 2. Same thing, mean is different, that's all. Everything going to be same. A power m whole power n going to be 3 power 2 into 3 by 2. Nothing in the denominator means 1. 2 2 cancel. This is going to be 3 power 3. Why? Because 3 multiplied by 2 to cancel, and this is going to 1. 3 multiplied by 1 is 3 divided by 1, and we are not going to mention that denominator of 1. This is something 3 power 3, which is nothing but 27. Going to the second question. 32 power 2 by 5. As we dealt with this question, 2 power 5 is nothing but 32 whole power 2 by 5. Same 2 multiply 5 into 2 by 5. Same law. Every concept here they're dealing with the law a power m whole power n. 5 cancel, 2 power 2 going to be 2 power 2 going to be 4. Simple, as simple. Your all chapters are as simple as that if you know law of exponents. Next, third question of second main. Third question of second main is nothing but third question of second main is 16 power 3 by 4. You know 16 2 power 4 2 power 4 whole power 3 by 4. This is nothing but 2 power 4 whole power 3 by 4 is nothing but 2 power. Solve on your own, guys. Don't wait for me to solve. You know how easy it is. 4 cancel. 2 power 3. 2 power 3 is 8. See, for this lesson I want you guys to read this. Read some till 0 to 5 of 2 and 0 to 5 of 3 and 0 to 4, at least 0 to 3 of 4, 0 to 3 of 5. What I am telling is learn at least 2 power 0, 2 power 1, such that of 1, 2, 3, 4, 5 till at least 0, 2 power 0 to 2 power 5 of same for all. At least learn the exponents of from 0 to 5 of 1, 2, 3, 4, 5. We are the last ones we are left for second main. That's 125 to the power of negative exponent, that is 1 by 3. What is 125 to the power of 1 by 3? That is nothing but, we know this one, how we are dealing now. Here that's something but 1 by 125 to the power of 1 by 3. This is 1 by 125 can be written as here, where is that, yeah, here 5 power 3 into 1 by 3. This is 1 by 5 power 3 cancels, you know, by multiplying 5 power 1, that is nothing but 1 by 5 is the answer. You can also write this as 1 by 5 into 5 power minus 1 because of that law. I hope you guys got. Now third main, we are dealing with third main. First question. Two power 2 by 3 into 2 power 1 by 5. A power m into a power n. What is that? A power m plus n. 2 by 3 plus 1 by 5. What is 2 by 3 plus 1 by 5? Take LCMs. I will write here 2 by 3 plus 1 by 5. multiply 10 plus 3 divided by 3 5 is 15, going to be 13 by 15. This is 2 by 3 plus 1 by 5, this is going to be 2 power 13 by 15. You should know how to take LCM here. LCM is nothing but this denominator is multiplying with this numerator, this denominator is multiplying with this numerator, and add those two divided by multiply these denominators, that is LCM. Simple one. Second question, see, this is the answer, 13 by 15. Second question is nothing but 1 by 3 power 3 whole power 7. This is so simple. This is something like a power something 1 power this, if you take this outer power to inner side, 1 power 7 divided by 3 power, already 3 is there, 3 into 7, that is 3 7 is 21. 1 power anything can be written as 1 only. This 1 power is 7 is 1, 3 power 27 is the answer. You can also write this as 3 power minus 27. You will learn why is this. Now going to third question. (11 power 1 by 2 divided by 11 power 1 by 4. This is so simple. Now if we are considering this nothing but a power m divided by a power n, a power m minus n, that is 11 power half minus 1 by 4. Take a reference, take a scale here, 1 by 2, let me adjust my screen, minus 1 by 4. 4 ones are 4, 2 ones are 2, 2 fours are 8, 4 minus 2, 2, 2 by 2, sorry 2 by 8 going to be 1 by 4, and this is going to be 11 power 1 by 4. This is your answer. So simple problems, dudes. What you just wanna do is just solve practice. Fourth one, this is of third main, this is of second main, this is of third main. Fourth one, 7 power half into 8 power half. This is simple. A power m into b power m. This is going to be a into b whole power m half. See, you should not multiply this. I have told why. And 7 8s are 56 whole power half. Yes. Finally we finished all the 1.6 exercise of first chapter. This is going to be the end of first chapter. You know how hard and how long it was. Why? Because this chapter is bit lengthy. Finally we finished, and I thank you all for responding and thanks for your patience. Now I just want you to tell that please practice this lesson at least for twice or thrice before attending or before facing your exams or first test. Why? Because this lesson is something a bit conceptual. You need to be hold of that concept, or to be in a great grip with respect to that concept in order to handle with that. Now I thank you all, and now I am going to conclude this last part of the first chapter. As usual, share among your friends and be safe. Have a good day. Thank you.